our next speaker. Alex is hailing all the way from San Francisco. He's an engineer at Netflix. His mantra, there will be bugs. He's going to talk to us about how we should not be scared of them. And let me put this here. We should not be scared of bugs, and we should not let them stress us out. Instead, we should be focusing on detecting them before our users do. So he will talk to us about how React and especially Redux can be used to stop worrying and start shipping bugs responsibly. Alex.
Thank you. Can you guys hear me fine? Great. How's everyone doing? Good? Awesome. This is my first time in Amsterdam. I got here yesterday morning. I'm extremely jet lagged. At this time would be probably 5 or 6 a.m. in San Francisco. But I have 4 coffees prior to this talk, so this should be fun. Great, so pushing bugs to prod responsibly. My name is Alex. I work for Netflix. My team is the Netflix Partner Platform Applications team. And I help Netflix, and my team helps Netflix to get to all the devices. So what that means is that whenever there's a new device in the market, let's say a new game console, a new smart TV, a new cell phone that runs Netflix, there goes through a whole process of certification. That's what we call it, where the device have to be basically implement the Netflix SDK in order to ensure that Netflix works and performs to our standards. So that is what I do at Netflix. We support thousands and thousands of devices, and my team, we build tools in order to ensure that this is a smooth process. But today, I am here to talk about bugs, right? And we all know whenever there's an issue in production. And I'm here to tell you how you can keep doing that, but in a slightly better way, in a way that you can actually recover faster. So before I tell you how we can make this happen, I think it is very important for us to understand our history. Where do we come from? And how technology has evolved since earlier days. So the story that I'm going to tell you actually starts in the 1800s. This is actually the year where the possibility of an issue actually emerged, right? So this actually happened when the analytical machine, this mechanical machine, was first created, and Ada Lovelace, who had designed an algorithm to run in this machine, actually acknowledged that there could be a malfunction somewhere, right? But the thing is that this actually was never proven because the machine was never really completed, right? So no bugs that anyone actually experienced. But it wasn't until a century later where the actual first programmable computer was created, and this was called the C3. I'm sure many of you remember that. And this computer was created, as they say, out of like a lot of telephone parts. And actual programs were able to be run in this computer. And then after that, when actually the term bug really took off. And the reason why this happened, like the term bug was used before this, right? But this is a very important year because this year was when it was actually documented, right? And it was because an actual moth was discovered in one of the relays on one of the computers. This is something that Grace Hopper documented on her diary. Okay, so let's go a little further. 1995 was when JavaScript was born. And this is a very special year because this is This is one of the reasons why we are here today, right? And I'm pretty sure many of you remember how intrusive it was when there was an actual JavaScript error in the browsers, and the user will actually get prompted with this huge window that will tell you, hey, you messed up here. Luckily, this is not the way we experience bugs today, right? So let's fast forward to 2017, right? JavaScript is 22 years old, but there are actually 18 million of software engineers in the planet, which 11 million of them are actually professionals. And we are shipping products very quickly, right? And what happens is that sometimes, but just sometimes, we are breaking stuff. And I'm here today, and let's just this quick exercise here. Let's get comfortable with each other, and let's just raise our hands if we've ever pushed a box to production. And I'm going to include myself right away. Wow, a lot of you are liars. Why are you not raising your hand? So I think it's important, I'm just joking, how much stuff we're breaking, right? Because I think once we discover that, we'll be able to proceed with more caution, and we're going to save our users a lot of headaches. Right? Let's just start to empathize with our users. I think we should know if we're responsible for this, right? We should know. So let's find out. But how can we find out? How can we know how much stuff we're actually breaking? I'm here to talk to you about instrumentation. Instrumentation is very important. Before I get onto instrumentation, I want to take a few minutes and just review what I'm calling the 7 JavaScript scenes. Right, let's get into the first one. Reference error. So how many of you are familiar with a reference error? So the thing is that we keep making these mistakes, and I'm pretty sure most of us here have actually had a reference error. It's almost impossible not to do it when you're learning to program in JavaScript, right? But the term reference error just doesn't mean too much, right? And that happens actually when you start referencing a variable that is actually not defined, right? For example, you include jQuery to your app, you include React to your application, or you thought you include React, and then you try to use it. You start using the React object, and it's just not really loaded in the document. So you get a reference error. You're trying to reference something that is not there. You can actually trigger it by just throwing a reference error. So this is one of the ways you could trigger if you want to see how it looks like. So syntax error. The syntax error is actually very, very common. Why? Because part of the learning is actually making mistakes, and it's about also one of the ways we actually try to do something in the language that the language is not supposed to be meant to use. So if you try to parse some JavaScript code that is actually invalid, you're going to get a syntax error. And I'm very happy that today we got to talk about linter, because we can take many precautions, and I highly recommend using a linter for this. We already know how valuable that is, right? But you can take as many precautions as you possibly can, and some things could happen sometimes, right? So we're trying to recover quickly. That means being ready for when that happens, no matter what. Linter is one of the ways we can take a precaution in order to avoid syntax errors. A type error. How many of you have issues with types before? Awesome. I've had issues with types before. One of the precautions that you can take for this is using a type system like TypeScript or Flow, right? And this actually happens whenever you try to use a variable that wasn't intended to be used that way, right? So let's say, for example, you have a number and you try to use a prototype method that is not part of the number prototype. a URI error. This is very uncommon because it's actually very difficult to get wrong a URI, right? But there's actually a dedicated type for this type of error, and it's called URI error. Whenever you try to use the encode URI or decode URI and you pass a string that is not actually a valid URI, you're going to get something like this. Then you have a range. Are you guys familiar with range? Some of these are very uncommon. One person. So a range is pretty much the ways you can see here that whenever you provide an invalid value for a given range. Eval. So this is actually something that browsers these days, they do not already throw anymore. And eval is something that is not common these days. The function still exists in the global scope. It happens when you try to parse an invalid JavaScript code as an argument passed to this function. So it has been kept supported just for backwards compatibility, but this is something that exists. Then we have an internal error. It's actually also very uncommon. This is, I think, only supported in Mozilla browsers. And this is whenever something goes wrong at the engine level. So if you do, let's say, too much recursion, too many switch statements, something that the engine, for some reason, it breaks internally, you could get an internal error, even though it's a non-standard. It's not in a track to be a standard. But still exists, right? OK, so how do we capture these exceptions in JavaScript? Are many of you guys capturing exceptions explicitly? The way you do this is actually by using a try-catch. If you have a try-catch block, you can actually run code within the try body. And if something goes wrong, if there's an exception thrown within that, you can actually catch it right here. And you can handle it in this block right here. But what do we get? We get an error. But what is an error? An error is actually an object in JavaScript. And this error actually has a prototype, just like any other object in JavaScript. And the pointer is still going. So the prototype of an error includes a name and message, which are probably the most two reliable properties, both containing strings, describing and naming the error. Then we have a couple of methods that are for utility purposes, are two functions, to source and to string. And then we have a lot of vendor-specific properties that are not in every browser there, so they're not very reliable to use. I think having just name and message is kind of enough to do what we're trying to do, to start instrumenting your application. So when we start instrumenting for exceptions, well, we need to have in mind that instrumentation is all about monitoring your application in order to capture errors and be able to get some information about the error so we can handle it in a way that works in our benefit. So there are many ways you can actually do this. One way, not the one that I'm recommending right now, but that I want to show you, is by using global event handlers. How many of you have ever used a window on error or an event listener? All right, so some of you are already capturing this. That's great. We are in a React conference. Today I'm here to show you how you can do it via middleware. And when I'm talking about a middleware, I'm talking about a Redux middleware. Have you guys used Redux middleware here? Actually, let me take a step back. How many of you know about Redux and have used it and understand it? All right, good. So do we need an introduction here for Redux? All right, so I'm just going to quickly, for those who are not familiar, tell you a little bit the Redux flow, which involves creating actions that are represented as an object literal containing a type and some data or some payload, that once that is dispatched as part of what we call the store API, you're dispatching an action, and that calls a specific reducer. And a reducer is pretty much a function that contains the next state of your application, just simply put, which forces a re-render of your React component. So it is a way to handle state, and it is an amazing way to solve this problem. So I want to talk to you a little bit about the Redux road. And when I say the Redux road, what I actually mean is the road where all the user interaction actually happen, right? If set up properly, Redux, you would create an action for all of your user interactions, which would return a new state, right? But what else happened in this road? This road has a lot of information. This is a great road. You know what also happens in this road? Exceptions. So we can actually capture exceptions in this road. And the amazing thing about doing it at this level is that you can actually get a lot of information about this exception at that point in time, exactly at that place, which is the Redux middleware. So let's talk a little bit about what a middleware is. In Redux, a middleware is pretty much a high-order function that it pretty much composes a dispatch function and returns a new one. And why is dispatch so important in this context? Why? Because that dispatch function is going to contain the actual action that the user created. So if we're talking about creating a Redux middleware, I'm going to show you a very simplistic approach to a middleware with basically no side effects, just so we can get familiar with the anatomy of a middleware. Great. So we said that middlewares are higher order function, pretty much. We use a function keyword, we give it a name, and then what happens is that we get the actual Redux store as the parameter, as the argument. This is great because that store contains the getState method. And getState is actually very powerful because by using getState, you can get the state of your whole application. And I'm going to tell you in a little bit why this matters. So this function returns a function containing next, which is actually the function that you can use to call the next action. And it actually contains the action itself. And this action object is actually exactly the plain JavaScript object describing your action. So if you were to do a store dispatch, the action would be that object literal containing type and text. Let that sink in for a minute. Ultimately, we return the action. Why do we want to return the action again? Because middlewares are chainable. So if we create a middleware and you're actually using another middleware, you want to make sure that the next middleware has access to that action. So we just basically do our side effects, and we return the action. For example, are you guys familiar with Redux Thunk, for example, for asynchronous? Okay, great. So if you're using Redux Thunk, and you have your custom middleware, you can chain them. And I'm going to show you in a little bit how to do that. After you have your middleware, you actually, by using Redux in your application, you can use the create store function and the apply middleware. And you can start using it by creating your store, basically including your reducer, including your apply middleware, which is just an utility in order for you to introduce a custom middleware. You can pass that middleware as an argument, as a parameter for that function. And that's pretty much everything you need to do in order to activate that middleware. So every time an action is dispatched, it's going to go through your middleware. Even right now, we're not doing anything with our middleware. We're just passing the action again. I want to get you familiar because we're going to start instrumenting with a custom middleware that is designed exactly to handle exceptions. All right. So a very simplistic approach for doing this is having the same custom middleware, using the store and getting the get state function, returning next an action, but then we use a try catch. Do you remember this guy? Try catch is exactly how we capture exceptions, and it gives you, if there's an exception, the error. We saw the error prototype. We know that an error is an object containing a name and a message with some other extra information. So if we just try running the next function with the action, if we just try to run the next function with the action, most of the time, let's say if your code is fine and you're taking the right precautions, nothing will happen with this try, right? So it's going to run smoothly. But we're here to account for that non-happy path, and that would happen within the catch block. So if there's something that goes wrong, by just calling that action, we get to the fun part, which is handling the error within the catch block. Using that error object to compose, let's say, a log. This log can contain a lot of things. I think what we care about the most is having the error itself. That whole object is actually very important. So let's say we compose a log atom with that error. And what I'm doing here, actually, is that I'm using the state. I'm putting the whole state of the application in this log. It could be huge. So depending on how you architect your application, you may or you may not want to do this. At the very least, you can get part of the state of the application by accessing from that state. Let's say you have user information. You know what the login user is, and you have other relevant information for this log. For non-huge state trees use cases, I would recommend probably using the whole state, creating a log containing the error, the whole state, and then using an exception tracking tool. An exception tracking tool can be custom built. You can create your own function that it handles that log, and let's say it could send it to the server. The goal here is to really get access to that log as soon as possible, whether you send an email, whether you send it to a third-party exception tracking tool, which we'll talk about. But you want to be able to know as soon as this happens, because you don't want exceptions being thrown in production for long periods of time. The actual lesson here is to try to know the issues about your app before your users have time to tell you. So we are using an exception tracking tool. And let's talk a little bit about what an exception tracking tools are. Anyone has used an exception tracking tool here before? Okay, this is pretty nice. I'm in the right place. Awesome. So I'm just here to mention a few of them. There's Sentry, there's Airbrake, there's Rollbar. You could build your own, of course. My team is a very big fan of Airbrake in particular. Airbrake has worked wonderfully for us. We're able to get a list of exceptions in real time, and you can see, this is just an example that I took from the website, so you can see kind of like how that tool looks like. And you can see that Grace Hopper had, 645 reference errors, because try to access an ID of an object that didn't exist for some reason or was undefined. This is great, because if we start getting data about these type of problems, as a software engineer, it really tells you what areas you should be working on. If you're getting a lot of reference errors, maybe you want to use a type system. Maybe you want to take the necessary precautions, right? There are many ways to try to avoid this, right? Ultimately, it's not about how to avoid bugs 100%. Bugs will happen. What we need to learn is how to recover quickly. We're humans. We write code. We make mistakes. We should be able to know how many times and how to recover from that. Something else that an exception tracking tool could tell you is the browser and the usage. You can see if the exception happened to be browser specific for some reason, you could have more context into where it happened, in what type of environment, and information that can help you reproduce this. That being said, we're talking about JavaScript here, but good exception tracking tools, they would probably support many languages. You can instrument the front end, you can instrument the back end. I would say instrument as much as you can, depending on your needs, right? A good exception tracking tool will contain integrations. So maybe you want those exceptions reported in your Slack channel, so you are more productive. Maybe you want that exception to be actually to create a Jira ticket for you, so you don't have to do it yourself and you can track it from there. There are many ways you can actually integrate with these exception tracking tools. Right, so what I've done to simplify instrumenting exceptions in my team, what we've done as a team is that we've created an actual Airbreak middleware that we use across many of our applications. It's on GitHub, it's open source. And let me tell you a little bit how that works. If we install Airbreak.js, which is their own open source client, and we install Redux Airbreak, we can actually, very similarly to the way we were applying a custom middleware, we can just require, import a Redux Airbreak, which gives you this object, right, or this function. Airbreak in particular, it takes, for that client to work, it takes an object containing a project ID and a project key, which is basically a way to say, okay, I know what project and what client and what account we're talking about here. I'm not going to log to just any account. I'm going to log exactly to the account that you need to. You pass your ID and your key. And then you can use the middleware that we've created in order to do this. And the same way we were using while creating a store, the apply middleware function from Redux, we just pass that middleware. And as simple as that, your app, your Redux app, your React Redux app should be instrumented for handling exception tracking tools and doing everything that I just told you about. Integrations, getting emails, getting notifications, getting analytics, getting a timeline, and everything that a good exception tracking tool has to offer. So as you can see here, we use create store, we use apply middleware. We have error middleware is what we pass as the parameter in the apply middleware function. And what we get out of it is that in that UI of an exception tracking tool, you can get a very good backtrace. You can see that it started at the very bottom here in the apply middleware function. And it bubbled up all the way to your library, and your store and your reducer. And this exception in particular came from a reducer, line 15, and column 55, while dispatching an action. If you're passing some part of the state or the action, you can get in this log your Redux action. So you can know exactly what action the user took before that error happened. If you got your whole state, you could get the whole state of your application. You can know the route of the, what was the route of the application. You can see everything the user did even before getting to that error. You can basically know everything you need to know in order to debug this exception properly. Great. I want to quickly mention how this middleware pattern can be very useful. We also use it with an open source library called Redux Tap, which basically exposes, creates a tap, you get a tap function that allows you to tap into these actions. The same way we were doing by creating a custom middleware, this pretty much simplifies it and allows you to tap into a specific type of action. So if we use tap, let's say our track function in line 4 is exactly the function that you use to log to your analytics. If you have a select analytics function, we just pretty much check that your action contains a meta property, and within that meta, there's an analytics object. You pretty much pass that select analytics, and then you get the event, the data from the actual action. And basically, in each action that contains the analytics action, it would trigger your function, and it will send to your third party. The next part where we've seen, if your action looks something like this, meta and analytics, it will be triggering, it will be sending an event to your analytics utility containing an event and data. So, instrumentation. Instrumentation is key. You need to let your code tell you things. Your code is your friend. You can actually write code in a way that you have a closer relationship and that you can actually start understanding each other more. It can tell you things. It can tell you when there was an exception. Use your code as your weapon. And let your code tell you things before your users do. So if there's something I want to leave you with, is that instrumentation is key. Thank you.